What is an empirical formula versus molecular formula? Empirical formula is a chemical formula that gives you the lowest whole number ratio of the elements in a compound versus the molecular formula, which gives you the actual ratio of the elements in a compound. So to further present this, let me give you this examples: CH2, C2H4, C3H6. There are there are two elements here, carbon and hydrogen. If you look at CH2, you have one carbon and two hydrogen. That means 1 and 2 are already in its simplest form. That means you cannot further simplify it. That means that this chemical formula gives you the empirical formula of the substance. On the other hand, if you look at C2H4 and C3H6, both coefficients can further be simplified because you can already divide it by a common number. That means that these two compounds are considered molecular formulas. While H2O is both considered the empirical and the molecular formula of your substance because it's already the real chemical formula, and at the same time 2 and 1 are already in its simplest form. So H2O can be both empirical and molecular formula. For this video tutorial, we're going to look at how to calculate for the empirical formula of the substances given the amount. So we will follow these steps that we will be employing for today. The steps in getting the empirical formula are the following. First, we will be given the percent composition of the compound. So if we're given the percent composition, very easy. What we need to do is we just assume 100 grams of sample. So if it's 100 grams of sample, we can just remove the percentage symbol and just make it into a gram unit, the unit of mass. So the moment you have already the mass in grams, you can readily convert it to moles, and the only data that you need for this is you use the molar mass of that element. Where do you locate the molar mass? You just have to look at the values on the periodic table, the atomic mass values. And the unit for molar mass is always the mass of 1 mole of a substance. And the moment after you get the quotient of the mass divided by the molar mass, you have to locate or look at what is the smallest or the smaller value and divide all the quotients with that smaller or smallest value. And the moment you divide it, you must get a certain whole number value. If it's not a whole number answer, you need to multiply it with a multiplier so that it becomes the whole number that you're looking for. Because this is the final step of getting the right coefficient of your element in the chemical formula. Now, to put this into action, we're gonna discuss one example on getting the chemical formula or the empirical formula of a compound that contains carbon and hydrogen. The question says, what is the empirical formula for a compound that contains 80.04% carbon and the remainder is hydrogen? So the first step is we need to look at how many carbon we have. You have to have the mass, which readily we just remove the percentage and make it as a gram. So we have 80.04%, which will become 80.04 grams of carbon. And then the rest is hydrogen because we have to assume 100 gram sample, so we need to subtract 80.04 from 100 to get the mass of your hydrogen. So we have two masses, 80.04 grams carbon and 19.96 grams of hydrogen. What do we do next? Second step is we need to divide it by the molar mass of each element in the periodic table. Let's start with carbon because the mass of carbon is 12.01, so we divide it by that value. And then we get 6.66 moles of carbon. Then for hydrogen, we divide it by the molar mass of hydrogen, which is, I round it up to 2 decimal places, it's 1.01 gram. Therefore, your answer is going to be 19.76 mole of hydrogen. For convenience, we will just express the final answer up to 2 decimal places. So that's why there are 2 decimal places for both moles carbon and moles hydrogen. Now let's go to the next step. The next step is we have to look at the smallest value or the smaller value that we generated. So the smallest value that we got is 6.66. That means we need to divide all the coefficients by the smallest value. So we will expect that there will be, wait, there will be, okay, sorry for that. So we ended up with the 6.66 moles carbon and 19.76 moles of hydrogen. So the next step is we choose the smallest value or the smaller value, which is 6.66. So we divide both answers by the smallest value, 6.66. So that's 19.76 divided by 6.66. So going to the calculator, of course, if it's the same, that's going to be equal to 1. So this is 1 carbon. And 19.76 divided by 6.66, you will get 3. So that is 3 hydrogen. We don't have any problem with the final answer because we clearly got a whole number. So 1 carbon and 3 hydrogen. Now, if ever you get like 2.99 or anything that's zero point 0.8 and zero point 0.9, just round it up to its whole number. And if you get a zero point 0.1 or a zero point 0.2, just ignore that, round that down to its whole number. So that's not going to be any problem. So right after this final step, we can already conclude the final chemical formula of your compound. So since you have 1 carbon and 3 hydrogen, therefore, the empirical formula EF of the compound is CH3. So CH3 is now the empirical formula, the final answer of this particular problem. So let's have an overview again of everything. So in everything, you see that you have to start with converting your percent to mass and then mass to mole, divide by the smallest value, get the whole number, and there get the empirical formula. So in this example, you clearly see that your carbon has to be divided, your mass of carbon has to be divided by its molar mass and also hydrogen, and the quotient, the mole values have to be divided by its smaller value. From there, just choose a smaller value. So you would expect that when you divide it by the smaller value, you'll always have a 1, and the rest you have to analyze if you get a whole number. So that's it for the first example of your empirical formula. So watch out for the second part so that we will have more problems related to empirical formula. Go to the second example.